So good morning everyone. In the last videos, we started a new course which is nothing but data structures and algorithms with Python. The timings of this batch is from morning 11 a.m. to 12:15 p.m. Monday to Saturday. Every day we will have the classes from 11 to 12, sir. The duration of this course is exactly 2 months. So maximum by the month of August ending, we are going to complete our syllabus. And the fees for this batch is rupees 999. And this is the contact number if you want to get registered for this course. And this is the content which we are going to share through Google Drive, running notes and videos. So videos access will be given for you up to 6 months. Next, the people who are attending. So this is my first class, sir. I want to refer previous classes. Like if anyone is there, just I am going to share the previous class recording session. You can able to watch that. 1 second, I will share you. In our YouTube channel, it is already uploaded. So in the playlist, you can able to check data structures and algorithms with Python at 11 a.m. So two videos are there because two classes we have taken yesterday and the day before yesterday. That videos are available here. Just you can able to go through. Okay. So the total content, whatever I discussed yesterday and the day before yesterday, that entire information is available in this playlist. So the people who are attending, this is my first class. Like if anyone is there, you can refer these videos, sir. Now, coming to the syllabus, in the very beginning day itself, I told very clearly what is the content that we are going to discuss. And yesterday we have seen some n-queens problem statement. Just for your understanding purpose, I have given what is mean by n-queens and how we can able to solve that problem, diagrammatic explanation, and even that code also I executed, but not explained. Then we have seen factorial of the given number. In how many ways we can calculate factorial? Total, there are three ways are there, right? So the first one is nothing but by using looping statements, how we can do. The second one by using recursion, how to implement. Third one by using predefined factorial method is there, by using that how to do that. And even we have seen the execution of these three functions. All these functions are giving the same result. This part also I covered very clearly in the last videos. And I have given introduction to the linked list. What is mean by linked list? How many types of nodes are there? What is the structure of a node also I explained very clearly. And we have four types of linked lists are existed. The first one is a single linked list. Second one is a double linked list. Third one is a circular linked list. Fourth one is a circular double linked list. Circular single linked list. Circular double linked list. So today I want to perform some two operations on the linked list. So first operation is just for your convenient purpose. Try to understand, but don't go in detail because we will see that part in detail. Consider this is nothing but, sir, this is nothing but some nodes which are available. Okay, I can say these are nothing but single linked list. Okay, we have some three elements are there, or I can say three nodes are there like this. Okay, let me take four nodes. Sir, last node next field is pointing to none, and the last before node next field will become last node, and this node next field will become this node. So this node next field will become this node. So there will be only one pointer will be there called as head. This is nothing but the first pointer in the node. Like we have some elements are there, sir. So I can say this is nothing but a single linked list, because you can see the structure of the node. We have only two fields are there. The first field is nothing but data, and the second field is nothing but it is a pointer which is pointing to the next node. Like that we have every node is going to associated with 2 pointers. First one is nothing but a data pointer. Second one is nothing but a next pointer. Like this we have. Sir, I connected multiple nodes and all these nodes are connected with the links. So this is nothing but a perfect example for single linked list. But don't worry, at the time of explaining the linked list, I will explain in detail. But now, just for outline purpose, try to imagine this is nothing but linked list. And one more point, every linked list contain any number of nodes. Sir, we can't give guarantee for these number of nodes will be present inside linked list. Maybe sir 10 nodes or 15 nodes. Like that, we don't have any restriction. So it can contain any number of nodes. We can't give exactly these nodes will be there. Such a type of limitation is not there. So do you know, in other languages, we have the data structure called array. The biggest problem with the array data structure is nothing but this one alone. It is a limitation. We have a limitation with the size. So that limitation is resolved in the linked list. Here you can store any number of values, no problem at all. So that's why how to identify all these nodes? We have to declare only one pointer. That pointer is nothing but head, which is always pointing to the first node. If you want, you can declare one more pointer called a tail also. But of course, the tail pointer will be used in circular linked list. Here it is not required. Sir, do you know we have two nodes are there? I mean, we have only one pointer is there, which is always pointing at the beginning. Can I say, is it a first node or not? Yes. The name of that pointer is nothing but a head. Head always referencing to the first node. This is nothing but a simple format for a single linked list. Sir, is this a terminology, technical terminology? Is it clear for you people? Please confirm.
Yes, sir.
Yes, I request everyone to please confirm. Is this a terminologies are clear for everyone?
Can you explain? I mean, head was not there. Just for your high level.
Sir, I while explaining for operations, you can get it, sir.
Okay,
No
okay,
problem.
okay.
Yes, I
So,
request everyone to please confirm. Is it clear? What is a single linked list? How this single linked list is represented? If you are okay with this, I will go with the operations on the single linked list. Basic operations I will explain. Can I continue?
yes, yes.
Yeah. Yes, sir.
Right, sir. So there are number of operations are there that we can do on this linked list. The first and very, very important operation is nothing but display. Display, or I can use traversing the linked list, or print the list. Okay, I want to write a code which is going to print every element present in the linked list. Sir, how to print? Since we don't know how many number of elements are there, we have to take a while loop to do this. Second one, we need to start with the first node and you need to reach to the last node. How to identify first node, which is nothing but head? How to identify last node? Last node next field is going to point to none. Based on these three, we can able to write the code, sir. Okay, let us see how I am going to write code for this. I am taking Python program. Assume def. I want to perform which operation? Display operation. I am going to write code for that. Sir, initially I am going to point if I am going to check one simple condition. If head is equal to none, then I am going to print the message saying list is empty. We can't able to print the content, and simply I am going to return the control. So otherwise, current node or temporary node is equal to head. Then while your current node, okay, is not equal to, while current node is not equal to none, we are going to print current node dot data, and we are going to make a current node is equal to current node dot next. That's all, sir. This is nothing but a small code to perform display operation. Sir, how it is going to work, just at the outline try to understand. So initially I'm going to check is head is equal to none. So when head will become none, sir, if there is no elements in the linked list, then automatically your head is pointing to none. No elements in the linked list means what? So a linked list is empty. That's why if head is equal to none, then I am printing linked list is empty. This is nothing but the worst case. Sir, my linked list is available because head is pointing at a 10th node. That's why what we are going to do. Already head is there, right? For that, I'm giving one more name, which is nothing but a current node. Okay. And I'm going to write, so current node will become this 10, sir. Okay. Current node will become this 10 initially. Right. Sir, is current node is not equal to none? Yes, the node is there, which is not equal to none. Then print current node dot data. If this is current node, we have two pointers are there. One is a data pointer, another one is next pointer. I want to print data pointer so that in the output screen, what output we are going to get? 10. Is it the first element content or not? Yes. After that, we have one more statement is there. What is that statement? Current node is equal to current node dot next. Current node is equal to current node dot next. Like that I am taking. Sir, now here, this is my current node, right? What is the next node to current node? It is nothing but 11. Immediately, current node is going to move to the next location. Okay, immediately this current node is moving to the next location. Like that, we are going to change. So now onwards, sir, which one will become current node? 11. Since it is a while loop, again it will start from the beginning. Is current node is not equal to none? Yes, it is not equal to none. Can you please print current node data? Yes. After that, again, can you move this current node? It will become 12 because current node is equal to current node tends to next. Now, what is a current node here? 12. So print its data, which will become 12. Now, what will happen? Your current node will become current node tends to next. Okay, your current node will become current node tends to next. Now, your current node is pointing to 13. Now, what is the content here? We have 13. Now, sir, where my current node is pointing? Current node is going to point to the none because what is the next node to 13, sir? Next node to 13 is nothing but none. Then while condition, current node is not equal to none. Yes, of course, current node is not equal to none. Immediately it will stop the process. Sir, these are the elements present in the linked list, right? Yes, like this we are going to get. This operation is called as display operation. Anyway, when we are discussing about the linked list, I will explain in detail, sir. But please make sure that up to this, at least if you can able to imagine the diagram and how we have written this code at the top level, it is clear means don't worry, in detail we will discuss in the linked list chapter. Just I am trying to explain the diagram simultaneously how we can able to write code. But if I start with developing the programs from the beginning, you people can understand very well. Can you please confirm, is this small code snippet how we can able to perform display operation? Is it clear for everyone?
Yeah, I have a question here.
Hmm.
This current node dot data is I mean method, inbuilt method or something.
It is a data, sir. Yesterday I explained, right? Every node is going to have two fields will be there. Okay. Every node is going to have two fields. The first field is called as a data. It can be any data, integer or floating point or string, anything. The actual content. That means I can say it is an object. And next one more field will be there. That field is always called as a next, which is going to point to the next reference. This reference is also of same type node. So this node is what? A single node. Okay, like that it is a format, it is a class. Got it? So that's why whenever this particular node is referenced as a current node, we can ask two queries on this. One is a data and second one, what is the next node to this? Like that we have two options. Here we are checking if that node is existed, we are printing the data and we are asking the next node to the current node, and we are making that the current node is equal to that one. Like this process will be repeated until you are getting none. Whenever you are getting none, what is the meaning? So we reach to the end of the list. Immediately we are going to stop this process. Clear?
Yes, yes. Thank you, sir. And the last note 13. Why it
Hmm.
is N you have written?
N means none, sir. None.
Okay,
NONE.
okay,
That means there
okay.
is no next node to that. That's why it is none. In other programming languages, we are using null.
Yes,
Since in
yes, yes.
Python we don't have any null, we are going to use null.
Okay. Thank you, sir.
Right, sir. Everyone, please confirm. Clear up to this, whatever I covered. Right. Okay. With one more operation on this linked list, I will stop this linked list because I am feeling that you people are trying to get confused with this. So I will explain one small concept in this and I will stop. So what is the concept here is I want to insert, okay, I want to insert a new node at the beginning and ending. So I have, this is nothing but I have a single linked list is there. My requirement is I want to add a new node. Okay, here I want to add a new node to the beginning. I can say this functionality is nothing but insert at first. Let us consider the data is 5. Next field initially none. And this name of this node is nothing but a new node. So now let us see how I am going to write the code. What is the function name? Insert at first. So we are going to give some data. That data, with that data, we have to create a node. That node will become new node. New node is equal to, we are creating a node with the given data. Sir, with the help of this, we are going to get a new node. Now I want to attach this node. Sir, we have two steps are there. What is the first step here is your new node is there, right? Its next field will become head. So new node is there. Its next field is by default empty. Now we are changing that to this one. Sir, a new node is attached at the very beginning. So immediately what will happen? Head is not a 10. Now your head will become 5. So for that, what we have to do? Your head will become new node. Your head will become new node. That means this is nothing but head reference variable from now onwards. Like this, whenever if you want to add the node, we have to add like this. But here there is one small bug is there. What is that bug is? Suppose if your head is equal to none, what is the meaning of this? There is no linked list. Then what will happen? Whatever node that you have created, that node will become the first node and we are going to terminate. So only two steps are there. What is the first case? If the linked list is empty, whatever new node that you have created, that will become only one node and head is always pointing to that node. What is the second case? If you have a big list is there, so you are creating a new node and that node next field already head is there, right? We are going to assign for that. And what will happen? The newly created node will become head node. Automatically these two are going to be attached. Now immediately that head is going to point to the new node which we created. So this is nothing but a entire list what we have. Now which is the head node, sir? 5, right? From 5 we can access all the remaining nodes. So I think you people understood how we are going to add a new node into the linked list. Any doubt? Please confirm. Any doubt?
No, sir.
Right.
So node, sir, in the second line, the node is you mentioned node, right?
It is a class, sir. It is a class. Of course, it is a small code snippet. Don't see in detail about the code because this is a predefined, I mean, this is a user defined class. We are creating object for this class, which is going to take a data and it will create a new node. It will return that reference that we are copying to new node, something like creation of object. Okay. Clear?
Yes, sir.
Right. So now I have this linked list is there. Now my task is I want to add a node at the ending, sir. Okay. I want to add a node at the ending. This is my linked list I have. So I want to add this node at the ending. So already we have some elements are there. So we have to perform insert operation at the ending. Let us see how we can able to do that. DEF insert at first we have seen. Now we are going to see insert at last. Sir, the process is the same, right? We are creating a new node. So we are creating a new node. So what is the content, sir? I'm creating the new node with the data. For example, consider I want to create a new node at the ending. Okay. So what is the data here we have is 14 and the last field is none. What is the name of this one? New node. Sir, listen carefully. Suppose if you have name of this particular 13, we can attach 13 next field to 14. But unfortunately, we don't have any name for this 13. That's why what we have to do, from the beginning, we have to move. From the beginning, we have to move. That's why, but there is one primary condition. If your head is equal to none, then what is the meaning? We don't have any list. Then whatever newly created node is there, that will become head node and we are going to return the control. If it is not the case, now I'm going to take a current node is equal to head I am taking. Sir, which one will become current node? This will become your current node. Now you have to move till to the 13th node. We know, right, how we are going to move. So until while current node next field is not equal to none, I'm going to take current node is equal to current node dot next. Now observe carefully. I'm explaining the code. Is a current node. What is a current node now? 5. Is 5 next field is existed? Yes. Then your current node will become current node tends to next. Now current node is pointing at 10. Is a current node next field is not equal to none? Yes. So now current node will become this one. Now current node next field is not equal to none. Current node will become 12. Now current node next field is not equal to none. Current node will become 13. Current node next field is none. So it will stop. Have you observed? We are creating a pointer at the very beginning and we are moving that pointer to the end of the node, that end of the list, almost at 13. Now we have a pointer for the last node and we have newly created node is there. So both names are there in our hand, right? Just we have to establish the connection. Sir, how to do that connection? Have a look once. Here I am taking your current node is there, right? Its next field is pointing to new node. Automatically, this next field will be deleted. And this is nothing but the pointer what we are going to get. That's all. We are not required to change any pointers here because the head pointer is there, right? By using that, we can come up to ending. The only task is you have to establish a proper links. And please listen one more concept here I am explaining. See, the time complexity for this program is big O of n. Means what? We have to take the first node and we have to move to the till ending. So how many nodes will be there? N nodes will be there. That's why it is going to take so big O of n time. Okay. So if you maintain a tile pointer, if you maintain a tile node, then what will happen? Big O of 1 is required because if it is a tail, then what will happen? The newly created node will become so tail dot next is equal to new node. Like this, we are going to take. So we are not required to write any. We are not required to write any while loop. This is nothing but what we have. Sir, for the simple single linked list, I explained 3 concepts. The first one is nothing but displaying operation. Second one is insertion at the beginning. And the second one, last one is nothing but how to insert the node at the ending. Sir, these 3 examples, diagrammatic wise and content wise, except code. Are you able to understand these terminologies? Please confirm. Any doubts? Clear?
Yes.
right? Yes, please confirm everyone. Only few people are responding.
Yes, sir.
Yes, sir. Yes, it's okay.
Clear, sir.
Right. So yesterday we have seen factorial application, right? Today we will see prime number application. We will create a small prime number application and we will see how it is going to work. Anyway, from tomorrow we will start our actual content. Okay. Yes, now I'm going to explain prime number application. Okay, prime number application. Sir, how you can say whether the given number is a prime number or not, we have to check. Let us see, sir. Prime number means what? If you take a number called 2, how many factors are there for 2? That means by using 1 we can divide this 2, and by using 2 we can divide this 2. So how many factors we got? Only 2 factors, hence we can say, so that is nothing but a prime number. Now if you take a number 3, so how many factors will be there for 3? This 3 is divisible with 1 and 3. So we have only 2 factors are there. Hence we can say this number is nothing but a prime number. If you take a number called 4, we are going to get how many factors? 1, 2 and then 4. So total how many factors are there? 3 factors are there. Sir, is it a prime number? No, because for prime number we know we are going to have only 2 factors. A number which can be divisible by 1 and itself. Such a type of numbers are called as prime numbers. Okay. Similarly, if you take 5, sir, is 5 is a prime number? No, right? Because it is divisible with, sorry, it is a prime number. It is divisible with 1 and 5. We can say it is a prime number. So can I say 6, is it a prime number? No, because it is divisible with 1, 2, 3 and then 6. Total how many factors we are getting? 4 factors. So this is nothing but a prime number. Prime number means what? It is a number which can be divisible by 1 and itself. That is how many factors will be there? Only 2 factors. Suppose if we are trying to get more than 2 factors, we can say that number is not a prime number. We have to implement a program for this requirement. Okay. So in how many ways we can evaluate, that part I am going to explain in today's session. Like in the factorial, here also we have 3 approaches are there. We will see all those 3 approaches one by one. Can you please confirm, is the concept is clear up to this?
Yes, sir.
Yes, sir.
Is the logic behind this program, is it clear?
Yes.
Right. So we have to see the implementation of this program. Let us see. Sir, I am taking, as usual, I am going to take a DEF. So prime 1 is the first function I am taking. We will write code later. And the prime 2 function I am going to take. So we will write code later. And the prime 3 function I am taking. So we will write code later. Like I am taking 3 functions. For each I value in the range of, we know prime numbers are going to be started from 2. So 2 to 11, I want to print in a formatted string saying that number I will print followed by tab space, and prime 1 I am taking by taking the number I, and slash t we are going to take prime 2 by passing a number called I. And we are going to pass another function. We are going to call another function. So prime 3 by passing I. Like this we are going to take. Sir, let us implement this code one by one. What is the first code here is, sir, for example, if the number is equal to 5, what we are going to do is, we will start dividing this number with all the numbers from 1 to up to that number. So we will check. Initially, we will consider factors is equal to 0. Is 5 is divisible with 1? Yes. Then we will increment factors. Is 5 is divisible with 2? No. then factors won't be updated. Is number is divisible with 3? No, the factor is not incremented. So number is 4, it is not divisible with 4, so it is not incremented. The number is 5, yes, 5 is divisible with 5, your factors will become 2. And if you take n is equal to 6, so we are going to divide with the 6, so 1 2 3, okay, so 4 5 and then 6. Sir, is the number is divisible with 1? Yes, your factors will become 0 to 1. And is 6 is divisible with 2? Yes, your factors will become 2. Is number is divisible with 3? Yes, we are going to get factors. Is it divisible by 4? No. Is it divisible by 5? No. Is it divisible by 6? Yes. How many factors we got? 4. But if it is a prime number, it should contain only 2 factors. That logic I am taking here. So initially, I am going to consider factors is equal to 0 for each I value in the range of, so 1 to n plus 1 I am taking. Then only it will start dividing the number from 1 to n. Suppose if n value is 5, we know range function will always exclude the second argument in Python. That's why to include that, we will take n plus 1. Automatically, n value is also going to be included. Now, every number we are checking whether it is divisible with I or not. If it is divisible with I, simply we are going to return that, if it is divisible with I, we are incrementing factors by 1 unit. At last, we are going to return if f is equal to 2. So if number of factors is equal to 2, then we are going to return true. Otherwise, we are going to return false. Like this, we are going to take. Okay. So I think you people understood the first logic, whatever I explained, and how I converted into program. Can you please confirm? Is it clear? Please confirm. Is the first logic how I converted into program? Is it clear?
Yes. Yes.
Now, sir, what is the next logic is? Please listen carefully. It is a bit tricky logic. Sir, when I am taking n is equal to 5, okay, so I will start dividing the number from 2 to 4. 2 to 4. That means only 3 numbers. If anywhere it is divisible, immediately I will stop by returning it is not a prime number. So if you exclude the first number and last number, it should not be divisible by middle of the numbers. If it is divisible, then it is not prime number, right? Like that, in the reverse case, I am taking just to reduce the number of comparisons. Okay. So here you can see, is 5 is divisible by 2? No. Is 5 is divisible with 3? No. Is 5 is divisible with 4? No. Then it is not a, then it is a prime number. If you take 6, so don't take 1. Start taking from 2, 3, and then 4, 5. Now check whether it is divisible by 2. Yes, then it is not a prime number. Immediately you can return false. How we can write code for this? Listen carefully. I am going to divide this number for each I value in the range of starting from 2 to n I will take, so that it won't include the value of n. If anywhere that I is that n is divisible with I, then we are going to return it is not a prime number. If this total function executed, at last if you are getting, then what is the meaning? It is not returned false, automatically it is going to return true. This is nothing but the second logic to check whether the given number is a prime number or not. So is the concept is clear up to this, whatever I covered?
Yes.
Yes, sir.
Yes, sir.
Right. Next, last logic, of course, it is a very, very important logic. By using prime number, how we can do? Sir, in addition to this, we have to pass one more parameter, sir. First, I will write the logic, then I will explain. So if the value of I is equal to 1, then we are going to return it is a prime number. So if that n value percentage I is equal to 0 means, then we are going to return it is not a prime number. Otherwise, I am going to call this a prime3 function recursively by taking n comma I minus 1. It is a recursive process. Suppose consider I have given n is equal to 10. Sir, in addition to this 10, we have to pass the value of I also. The I value is nothing but a 10 by 2, exactly half. If a number is divisible, that is, if 10 is divisible with 1 and 5, automatically it is going to be divisible with after 5 also. Okay, that is the basic thumb rule, right? Okay, if you take a number called 100, if it is divisible from 1 to 50, definitely it will be divisible from 50 to 100 also. Like that, I am taking exactly half. Sir, I value is nothing but what now? 5. Is 5 is equal to 1? No. Is 10 is divisible with 5? Yes. Then immediately it will return the message saying false. Sir, how many comparisons we have taken? Only one comparison. Okay. Suppose if n is equal to 100, then what we are doing? Your I will become so 100 by 2, which is nothing but 50. Sir, first condition, is your I value is equal to 1? No. Is n is divisible with I? Yes. Then immediately it is going to return false. It is not a prime number. Suppose consider I have given n is equal to 7. So what about I value? I am taking 7 by 2, which will become 3. So is it equal to 1? No. Then is it divisible with 7? No. Then what will happen? We are calling the same number 7. So by passing the value of I as a 3 minus 1, that is nothing but a 2. So is I is equal to 1? No. And is 7 is divisible with 2? No. Then what will happen? Again, we are taking the same 7. So your I value will become I minus 1, which is nothing but 1. Now is your I is equal to 1? Yes. Then immediately we are going to return true. So in this example, how many times the loop is going to execute? I mean, how many iterations we have checked? Only 3 iterations. Like that, if you want to reduce the number of iterations, we can go for this prime number logic by using recursion. Sir, among these 3 approaches, which approach is the best? Means we can say directly recursion approach is nothing but the best. Can you please confirm, is these 3 concepts are clear for everyone?
So the last concept, can you explain again?
Sir, yes, sir. One more time, please.
Sir, here we are taking a number. If you take any number, for example, consider n is equal to 5. So first I am going to divide this 5 with 2. So 5 by 2 value is what? 2. So we are checking, is it divisible with 2? If it is divisible with 2, multiples of 2 also will be there, right? Which is nothing but 4. So is it divisible? No. Here we can say 5 is not divisible with 2. Then immediately your I is not 1 and your n percentage I is also not equal to 0. Then we are passing same n value, but you are taking I minus 1. Your I value will become 1. If I is equal to 1, then directly we are going to return. So instead of the number of comparisons, so we got only how many comparisons? So we got only 2 comparisons are there. Within 2 comparisons, we came to the conclusion. Now let us take one more example. I am going to demonstrate. Let us take one more example. What is the next example here is, suppose consider n is equal to 12. Sir, now what is I value for this? Exactly half of the number we are going to take. So 12 by 2. 12 by 2 in the sense 6. Now we are going to check, is your number, that is I is equal to 1? No. Is n percentage I is equal to 0? Yes. Then we can say it is not a prime number. Have you observed? If a number is divisible with it's a half of the numbers, automatically rest of the numbers also it is divisible. I am applying this small trick, sir. Beyond that, nothing. So this is nothing but the recursion what we have. Anyway, in the recursion chapter, I will explain in detail. But is the concepts are clear up to this? Clear, sir?
Yes, yes, sir.
Yes.
Yes, sir.
Yes,
Sir,
right.
hello.
Hmm.
Sir, is there any is there a separate chapter on recursion? For
Yeah, we are having. These are demo sessions, sir. It is not the actual content. Okay.
Okay.
We are going to discuss this in detail. There is one chapter is there called recursion. There I will explain in detail because it is a demo session. I am giving overview. From tomorrow, the regular classes are going to be started. From the first chapter, we are going to see tomorrow. Okay.
Okay. Okay.
Right. So now I want to execute this code and I want to check whether it is working properly or not. Let me check. Sir, here we have given only I by 2 also we have to provide. Now I am going to run this program to test whether it is working properly or not. So py space I am taking test.py. You can see is 2 is a prime number. Yes, in all these three cases, we got positive result. Is 3 is a prime number? Yes, in all these cases, we got a positive result. Is 4 is a prime number? No. Is 5 is a prime number? Yes. Is 6 is a prime number? No. Is 7 is a prime number? Sir, here we are getting none. Somewhere the problem is there with recursion. Now you can cross check the recursion logic. So here you can see prime 3, n comma I. If I is equal to 1, we are going to return true. So if n percentage I is equal to 0, then we are returning false. Sir, here we have to take a return. So like this we need to take. Now cross check whether it is working for 7. Yes, 7 is a prime number and 8 is not a prime number, 9 is not a prime number, 10 is not a prime number. Like that, just how many ways are there to check the prime number or not prime number application? We can verify by using 3 ways. Anyway, in detail about this, we will discuss in our further sessions. Any doubts up to this? Clear, right?
Yes, clear.
Right. I request everyone to register for this course. So tomorrow will be the last demo session, and tomorrow we are going to start our actual content. From tomorrow onwards, we are going to share these running notes, videos, everything. So tomorrow is the last demo session, and from day after tomorrow onwards, we will have our regular classes. Okay. Right. Thank you, sir. We will meet for the continuation tomorrow. Thank you.
Thank you, sir.